Now we're going to find tangent lines of implicit functions. So we know to find a tangent line, I need a slope and a point. Well, looking at number 1, they've already given me a point, so that's a nice bonus. I will need the slope. The slope is the derivative. So let's now take the derivative of this implicit function. It starts with the natural log. So natural log is going to be 1 over what I have times the derivative of the inside. The derivative of the inside is going to be using product rules. So f prime g plus fg prime. We're going to start out with the derivative of x is 1 times y plus x, and the derivative of y is the y prime, or dy dx, however you want to write it. And then the derivative of 2x is 2. So I'm going to rewrite this just to make it a fraction. I'm going to go ahead now and cross multiply. So I have y plus xy prime equals 2xy. Subtract the y over, and I have xy prime equals 2xy minus y. And then lastly, I'm going to divide by x. So the derivative is 2xy minus y all over x. Now I'm going to need to plug the point in. So I have 2 times 1 times e squared minus e squared all over 1. So 2e squared minus e squared over 1 is going to come right down to having a slope of e squared. So y equals mx plus b, y value of e squared, slope of e squared, x value of 1, solving for b, subtract the e squared, b equals 0. So you can write, you have the function of y equals e squared x, and that's your tangent line. You could also use point slope and write 1y minus e squared equals e squared times x minus 1. All right, let's look at the next example. Find all points where the tangent line to that gorgeous function is either horizontal or vertical. So a very short question and a lot of work for us to do. So first thing we're going to do is working with that horizontal vertical, we're going to know tangent lines, we need the slope. So go right into it and find the derivative of this. So the derivative of y cubed is 3y squared times the derivative inside y prime minus, open a parentheses, do product rule. Here we go. We've done this one very recently. So we start with, it's going to be 1 times y plus x times y prime equals, the derivative of negative 6 is 0. So 3y squared times y prime. Now distribute that x negative through. So you have negative y, negative x, y prime equals 0. My next move is to get the y primes together. So I have 3y squared y prime minus x y prime. I'm going to add that y to the other side. GCF out the y prime, and you'll have 3y squared minus x. Okay. Divide by that 3y squared minus x. And we have now found the derivative. Yay, us. Okay, so how does that actually help answer the question at all? So we start with, if I have a horizontal tangent line, that means the numerator is equal to 0. So, okay, so if I have a horizontal tangent, then I'm going to say, all right, numerator equals 0. So I say y equals 0. So far, so good. Well, I need to have a point, so I'm going to plug that new 0 into the original. So let's just rewrite that y cubed minus xy equals negative 6 to solve here for x. So 0 cubed minus x times 0 equals negative, oh no, 0 does not equal negative 6, okay? So that's impossible. There are no horizontal tangents. right, well, you win some, you lose some. Next, we're going to say, all right, are there vertical tangents? Vertical tangents, I'm going to pick up a different color so it's not as confusing. Vertical tangents is when the denominator equals 0. So now we'll set the denominator equal to 0. So we're going to say vertical and needs the denominator equal to 0. So that's going to be 3y squared minus x equals 0. Just slide the x over, so 3y squared equals x. Use the same plan, plug that into the original. So I've got y cubed minus xy equals negative 6. I'm going to plug in, so y cubed minus, there it is, 3y squared times y equals negative 6. So y cubed minus 3y cubed equals negative 6. So negative 2y cubed equals negative 6. So y cubed equals positive 3. Take the cube root and you'll have the cube root of 3, or we could say it's the decimal of 1.442. So there is the x value, there is the y value. And now we'll need to plug back in to the original again to find out what the x value is. I'm going to use the cube root. I feel it's going to be a more accurate answer. So the cube root and the cube cancel each other out, and I have the cube root of 3 times x equals negative 6. Subtract the 3, and I will have, negative cube root of 3x equals negative 9, or x equals 9 over the cube root of 3, which is equivalent to 6.240. So we did not have any horizontal tangents, but we're going to have a vertical tangent at the point 6.240, comma 1.442. Now there's one more example for you to try. There you go. Go ahead, find the derivative, work your way through that, pause the video. And there's the answer. Have a great night.